Geometry, Unit 8, which is Chapter 6 from the book. Section 4, Proving Circle Conjectures. So what we're going to be doing in here is we're going to be doing a bunch of flowcharts, flowchart proofs. So this first one is one that we get from the book. And the idea we're trying to prove is that circle center is on the inscribed angle here. So we're given circle O with the inscribed angle ABC. So this is our inscribed angle ABC. And has the diameter of BC. And we have to show that the measure of angle ABC is half the measure of the arc AC. So we got to show that. So let's walk through this proof. First, we have AO is congruent to BO. So AO congruent to BO. And we know that because it's the radius of a circle. So there we go. We've got that. So then that gives us that this is an isosceles triangle. An isosceles triangle has two congruent sides. So that's an isosceles triangle, which then leads us to angle X is equal to angle Y. So we have this angle is congruent to that angle. And step 3 here, we know angle X plus angle Y equals angle Z. That's the triangle exterior angle conjecture. So this angle is the sum of these two. And so then we go through some math. We do a little bit of substitute. Since X is equal to Y, we can substitute it in. So I take this equation and I substitute the X in for the Y. So I get X plus X equals Z, which is 2X equals Z, divide by 2, and I get X equals 1/2 Z here. So taking that step, combining it with our given of angle X is equal to the measure of angle ABC, and Z is the measure equal to the arc AC, and that's because our central angle is the same measure as the arc it creates. That gives us angle ABC is equal to half the arc. All right, let's walk through a flowchart proof of our own. Let's create this here. So we're given that the radius from circle A to this point C is perpendicular to the chord BD. So we're given that. So we got AC's radius that's given. AC is perpendicular to BD. That is also given. All right, so next step I'm going to take, I'm going to say AB and AD are radius. So AB and AD are radius, which means I will then be able to say that they're congruent. But the reason I say they're radius, that's the definition of a radius. So given that, that means AB is congruent to AD. Also definition of radius. And then I'm going to say AE is equal to AE. That's the reflexive property. Now, I'm going to combine the perpendicular with the reflexive with this property. Combine all of those together. So I got all of that. And now I can prove triangle ABE equals triangle AED by hypotenuse leg. And then that gives me BE is equal to ED by corresponding parts of congruent triangles are congruent, which proves AC bisects BD. It's the definition of a segment bisector. All right, let's prove another one. So here we go. We got AB and AC are tangents to the circle D. We have to prove AB and AC are congruent. So the first thing we're given is AB and AC are tangents to circle D. I'm going to now state that BD and DC are radius, which means BD is equal to DC. These are both because definition of a radius. Tangent, property of a tangent means angle B and angle C are 90. That's the definition of a tangent. So we've got this is 90, this is 90. I'm going to state now that dA equals dA. That's reflexive. And I'm going to combine all three of these together to state that triangle DBA is congruent to triangle DCA by hypotenuse leg, which then tells me that AB is congruent to AC because of corresponding parts of congruent triangles are congruent. And that is the end of this lesson.